like the water.
All right, so the first one, number 9, what I'll call the first one, we will cycle back after this unit back to similarity. So it's good to have that. And here's one on an SAT test. So it says that those two triangles, they're right triangles, and it says they're similar. What does similar mean? Okay, so criteria-wise, the angles are congruent. Corresponding angles are. And what else?
Lengths are not like the exact same.
True.
Like multiples of each other.
Yeah, good. So we use the word proportional. Yeah. Right? He said multiples. That's good. It doesn't have to be a whole number multiple. And then it tells us which angles are corresponding. So can you do this problem without a picture?
No.
You can if you remember the name rule. I suppose you call it a rule. Do you remember how we can use the letters in the name to know which angles go together? Yeah, it's like first, second, third. Like the name goes in the same order. So any position in there, like N goes with R, because it's in both names, it's the last letter. Okay, that's a big deal, because it tells us that M goes to Q, and then down here it tells us M has a measure of 53. So what is Q? 53. So this can be like a 10-second problem, like 5 seconds to read it, look at your name, M and Q are the same, done, right? Which saves you time. But it could be a little bit longer if you drew the picture out. And then, of course, if you start doing calculations, then you're probably really in trouble. If you drew this, maybe L, M, and N, and then P, Q, and R, you just have to make sure that you label it in the same order as you go around. Now we can see that M and Q go together. So if this is 53 degrees, then of course that is as well. Because this whole thing depends on knowing what similar means. And it's not enough to say they are not the same but alike, right? That's not good enough. So let's review these again. We had 2 criteria for figures to be similar. What was one of them? One of them. What was it? How do we know if figures are similar? Awesome. Okay, and then what was the other one?
Side proportional.
Yeah, and we have to use that corresponding word again. Corresponding sides are proportional. What does proportional mean? Like, it's okay to say it, but we have to know what it means. I'll give you a hint. I'm going to write 2 ratios, and you're going to tell me if they're proportional. We'll start easy. Are those proportional? And so I'm asking, do they have the same value, right? Yeah, this is 0.75, and so is that, because it's just 10 times both, right? So tell me something, if I put it down here, it would not be proportional.
50.
Yeah. So this would be 3/4, this is 3/5 when you reduce, which is not proportional, right? It has to be the same ratio value. And do you remember how to solve a proportion? We did this last week as a review. Butterfly, right? So cross products. So this would be 3x equals 120. And then just solve. From there, you just solve like normal. Does that all ring a bell? It's coming back. Probably in about a week. Maybe less. All right, next one. Which of the following equations is the most appropriate linear model for the data shown in the scatter plot? So if we look at this, these are all in what form are they in? Slope is one word, but we have to have another word. slope, intercept. And what form is that? Like what letters do we see? Okay. Mx plus b, what is m? Like what does it represent? I mean, yeah, that's the slope. Good job. What is b? Awesome. That's the y-intercept. So if you notice, these are all the same number with different sign. So, excuse me, this is really knowing, what the heck's going on here? This is really knowing which of these would potentially match that line, right? That's really what this is asking. So which two can we throw out immediately? A is one of them, not B though. C. Why can, let me unscratch them out. Why can A and C be kicked out right away? What is? Then, yeah, this y-intercept is negative 10. And if we look on here, that would be like down where these words are, right? So we can't have a negative y-intercept when it's up there. How do we decide if it's B or D? Well, you're really asking the first sign of 1.9, right? Which one of those makes the line downhill? B. Good. Alright, let's do these really quick. You spin a spinner and then roll a die. Is that independent? Huh? Why not? Yes. But what does independent mean? Yeah, if I roll a die and spin a spinner, does one affect the outcome of the other? No, not at all. These are independent. You draw a card at random, then draw another without replacing the first. Are those independent? Let's say I'm only holding 5 cards in my hand, and you pull one out, and then I take him over to him. Does he have the same probability as you? So are those independent? Guys, are they? Do you get it, or are you just saying no because someone else did? So I'll tell you that it's a fundamental concept to get through these and probabilities. If you don't know this, you're not going to answer. Like, if you say yes, it's independent, and it's not, your probability is doomed from the beginning. So, how about this? Choose a raffle ticket from at random from each of 2 different bags. Maybe you're trying to pick winners. You're picking one from each bag. Are those independent? I have a yes, and a no. What do you think?
You got it.
Well, it's 13.
Yeah.
Read it. What about you? You think those are independent or not? Well, things will get bigger, but the question is, if I draw a raffle ticket from 2 bags, are those the probabilities of those independent? She says yes. Silvana? Bailey? Hayden? You said no, right? You said no? You are outvoted. Yeah. These are definitely, like, do the 2 bags affect each other? That would be like saying draw a card from 2 different decks of cards. Like, does me drawing a king here affect if I get an 8 over here? Not at all, not even a little. Okay, you draw a name from a bag and return the name, shake the bag, and draw again. Independent or not? What makes it independent? Yeah, if I stick it back in there, isn't it like Bailey used the word yesterday, reset? Isn't it resetting? Like I'm starting over, like the first draw never happened, right? think you should just adopt the rule that whatever you think, it's the opposite. I'm a little concerned. I want you to just read this again. Or maybe we didn't write it clear enough or something. I didn't put it here because I put it at the bottom of this page. Is it independent? Does one affect the other? So, you know what? Let's make it super clear where you're probably going to look for the formula. So I'm going to put it right here. If you feel like you have a handle on this 100%, you probably don't need to write this. But I didn't get the feeling that that was true. So I probably would, if I was you, write this down. Independent means so does one event occurring affect the probability I'm having trouble writing that word. Give me a second. Affect the probability of the other event occurring. If it's no equals independent. And then yes equals conditional, which means not independent. Okay, start just making up examples in your head. And I'll ask you some that come to my mind. Weather and precipitation, are those independent? If I said, what's the probability of some weather phenomenon, and what's the probability of precipitation? Are those independent? Does one affect the probability of the other? Yes, so not independent, right? Weather, if it's 100, it's not snowing. If it's 10, it might snow, right? Like it does affect that probability. Does weather affect what we do in this class? So probability of taking notes and weather. Not at all, right? Like it doesn't matter what's going on out there. So if it's no, it doesn't affect each other, then it's independent. Okay? Is this helping? Clarify. This is really important to know because if you use the wrong, like if you use this formula when you shouldn't, obviously your probability is wrong. So back to this, spinning a spinner over here, rolling a die. Does me spinning a spinner affect the die, the outcome of the die? Not at all. I'm going to skip down here. Again, drawing something from two stacks. Does that change? Does this one change that one? No. Draw a name from a bag. Put the name back in. Now I'm starting over, right? So does drawing the first name affect drawing the second name if I stick the name back in? No. Is that kind of helping? Those are all independent. This one, you draw a card and don't put it back. Well, now there's less to pick from, right? All right, well, with that said, let's starting with the non-independent conditional probability. We looked at this very briefly yesterday with this table. Does anybody remember the name? I don't think it says it up there. It was 4 words, one of them being table. It had a number in it. It was this and this. Two-way frequency table. Frequency, remember, was just talking about how many times each thing showed up in there. That's all. Okay. And then I asked you this: what's the probability that a member of the art club selected at random is a junior? And we picked up on the fact that we had to look at the art club. And then out of that group, how many were juniors is the probability, right? Yeah, so this was 16 out of 58. And how did we know to not look at 16 out of 40 instead?
Because it's just the junior class.
That would be, the category would be the juniors instead, right? Okay. And that would be a different way of wording the same two things. We would say, what's the probability that a junior is in art? That would be the difference. And this one is the opposite. What's the probability that an art club is a junior? Do you hear the opposite nature of that? Okay. We have notation that shows that, and you can see it right here. So we're used to writing P with some event in the parentheses, but now we're going to add this line in between the two events. Instead of the word or and, we're going to add this line. And this line is this phrase, given that. That's the line right there. I'll write it in your notes, but that's what it's saying. So this is probability of B given that A occurred. Okay? So let's try this. In a standard deck of cards, how many kings are in there? There are 4 kings, right? So, what's the probability of drawing a king? I just walk up to you with a fresh deck and say, here, what's the probability of a king? Okay? It's 4 out of 52. There's 4 kings out of 52 cards. Okay, so what we're going to see is this change. What's the probability of drawing a king given that, so that line, I know it's weird, but that's what it says, given that Hayden drew a king already. Well, what would that probability be? 3 out of 51. It's different, right? Because we know something happened, it changes our answer to the first part. Without that, if it's just raw, here's what's the probability of a king, we don't know anything, we have to go with 4 out of 52. But once we know something happened, sometimes it changes that, right? And in fact, the only time we'll be using this notation is when it does change. Make sense? Okay. That is called conditional probability, and it's when we know something that affects the probability of the next thing. And there's lots of cases of that, right? Like, what's the probability that I go a different road to school? Given that I know that there's an accident on the road I usually go. Something like that, right? And our brain processes through this all the time. It just doesn't put numbers to it. So let's put some of this in your notes. We'll come back to that equation in a moment, but said in a moment. It'll probably be just a little while before we do that, actually. Okay. Are you guys doing okay with the word event? Meaning anything we're interested in, right? It's not like a concert. Are we good on that?
Mm-hmm.
Okay. So conditional means knowing one event already happened. And here's the big idea. That changes the probability of the next event. So you think of Christmas, it's like a gift giving season. And let's say you're really hoping to get something that you wanted. If you just look at it from that perspective, hey, I really hope I get this, the probability is kind of wide open, right? Like you may or may not at all. But if you know, so knowing something happened already, you asked for that thing and you happen to see your mom on the website where you would get it, does that change the probability that you'll get it? Probably, right? Like now you know, hey, I did mention it and I thought I saw her on there looking at it. You're probably more excited, right? That's like a natural response. Like, and your brain is processing that. Given that I saw her on that site, probably is a good thing, and I'll probably end up getting it or something, right? Like that's kind of a recent example. That's what we're talking about here. So knowing some information changes the probability of the next thing that we're asking about. Okay. Let's write about notation. Okay. So with these, you'll see that line in between. It is easy to get confused about which thing you know and which thing that you're trying to figure out. So let's try to address that now and make a good habit. So here's how I'm going to do that. I'll put some words over there, but let's clarify. You're trying to figure this out, the first thing. This is the thing you know happened. And then what does that line say? Yep, it says given that. Okay, get that down. Here's what I want you to write. So this notation is saying the probability of A given that B already happened. Now, this word happened is going to be weird when we look at these tables. Like the art problem, the junior and the art. The happened was the art class, like the art club, I mean. So, being a little bit broad in your meaning of happened is my point. Maybe an illustration. Probability of I thought of a good one, but I think it's probably a little too hard for me.
I'm
Huh?
serious. What is it?
Okay, how about this one? Probability of getting sick, and then over here, put friend sneezed on you.
That depends on your views. Yes.
Do you think this way? You guys know I do. But do you think this way? Like your brain kind of does. Like, oh crap, that person just sneezed in my face. You know, I hope I don't get sick. That is saying, what's the probability just changed because this happened, right? Like, oh, I'm not even thinking about it. Oh, now it's up. It's that. Like, our brains understand this kind of naturally. So, if you want the statement, you might already know this, but, I can't write it. Give me a second. There we go. What is the, and let's abbreviate, probability of getting sick given that my friend just sneezed. Okay? That's what that says. Isn't it nice that we have notation so we don't have to write all that out? What is the probability that you get in a car crash given that the roads are icy? Knowing that information changes the probability.
Is it black ice?
What?
Is it black ice or normal?
I mean, ice on the road. It's bad no matter what.
But it's true, but black ice is way worse.
Well, it is because you can't see it.
Yeah.
Any questions on the notation? Okay, we'll come back and add a couple more things, but let's put this to use. All right, look at this. First of all, do you notice the difference? Are these different? Like probability-wise? Like obviously the writing is different, but do you think the actual value, the answer would be different if we switch the letters around? Like A, what's the probability of A knowing B happened? What's the probability of B knowing A happened? Do you think those numbers are different? They are. Sometimes a lot different. Okay? So be careful that you read it the right way. Okay? We'll see that here in a second. So, really pay attention to this. It's too hard to write down all this stuff, so just pay attention up here. What is the this is that same table, just so you know that it's the same context. What's the probability that a member of the drama club is a sophomore? Okay, pause here. Do you hear two things, two categories? Okay. Are they independent? That's our first question still. Otherwise, we're not even going down this road. They're not independent. Certainly a sophomore can be in the drama club. Or a drama club member can be a sophomore. It's either way, right? It's not independent. In other words, it's conditional. All right. That is how a question will be asked. It is sometimes. It is your job to be able to write that in the notation. So look at the notation. Which one should come second? Like, which thing do we know? I'm about to show you, but in our little P, A/B, which one is the known thing that we already know happened, is my question. Well, you just said both of them. Only one of them can be known. We're trying to figure out the probability of the other one. Okay, so everybody's saying sophomore. It's actually this
Drama.
is what we know. Right? So here's the notation. Remember, it's figure out, and this is known. So let's figure out, let's relate it back to the sentence. What part of this is there's a name for it in your ELA class. It's like the something clause. I don't remember, the independent clause or something maybe. What is the thing I can pull out of here and still have a thought? What is the probability a member is a sophomore, right? Do you hear that in it? We're trying to figure out this probability word links to sophomore, not drama club. We already know that, right? Do you see how it kind of sounds in a sentence? What is the probability it's a sophomore? That means the figure out part has to be the first one. And then drama is known, so it's the second part. So everybody's kind of making, it's going to take some time to get this, I think. But all right, now we have to go to the table and decide which is the category that we're looking at. Here are your two options. Are you looking here, or are you looking here? Horizontal or vertical, based on that question. What do you think? What did you say? Okay. Anybody else? Vertical. Horizontal. We're gonna split right down the middle. I know. Kyron, what do you think? Okay, she broke the tie. It is actually vertical because we're saying a member of the drama club. So that directs you to pick from the drama club. Then is a sophomore says out of the drama kids, there's 3 sophomores, right? So this should be equals 3 out of 17. Okay. Now, look at this. We're just switching the words. That's all we're doing. What is the probability that a sophomore? What do we know now? Now this is known. Is a member of the drama club. Again, the thing we could pull out, whatever clause that's called, what is the probability whatever student is a member of the drama club? Do you see how we can pull out the known piece and still have a question there? If not, like if you pulled out this part, that doesn't make sense. What is the probability that a sophomore? Like, what are we asking, right? You can't pull off the part you're trying to find, but you can pull off the known part. What is the probability that student is a member of the drama club? It does finish. It makes this thought complete. Notice our notation is backwards now. Not backwards, it's just the other order. So which one now are we looking at? Horizontal or vertical? Now it's horizontal, right? We know that it's a sophomore. That means here's our sophomores. Now we're saying which of them are drama members. That's 3 out of 36. So look to Bailey's question earlier. Or not question, but my question that I asked everybody. 3 out of 17 is totally different than 3 out of 36, even though it's the same 2 things we're talking about. Okay? So, what did you learn from that? I guess one thing you could maybe address is how do you know which way it is? Could you summarize that for me? How do you know if it's horizontal or vertical?
What you take out, it still makes sense as
Is your direction, right?
direction.
Okay. Did you notice? So she said, if you didn't hear, whichever part you could take out of the question and have it make sense is your direction. That's your category. So, did you notice that that piece is always second in here in the probability notation? This is the removable piece, and here we are. This was the removable piece. It always comes after the line. Okay. Let's put that note on there. That we're going to say it a little bit more functionally. So the event after the line, I don't want you to write B, because we just saw it switch. So this is just an example notation. The event after the line is the category, and here's the bigger deal. It's the denominator. So when you go to set up your probability, it's the denominator. So it's not written on here. I'll just write it. And don't shout it out. Let me finish writing and then I'll ask everybody. So start thinking about that. I'm going to flip this next one on you. Not flip it, switch the idea a little bit. Okay. So come up with your numbers for this first one, and then I'm going to have everybody say it in a second. All right, go ahead. Say both numbers, so we're going to give it as a fraction. Go ahead. Good. 13 out of 40. We know the kid is a senior. We're asking how many of those are, it's not 40, it's 39. And there we go. We know the kid is a senior. That sets the category. And 13 of those are science. Sorry about that. Okay, how about this one? Now it's 13 out of 40. Now, in this case, those are almost not different at all. Okay. Let's drop down to here. So take a second to think of your numbers. Well, there's lots of chairs up here.
No, it's because it's bright, light blue, so that's why I couldn't see.
Yeah, it is kind of hard. Art is 24. Total art is 58. Okay, tell me your numbers on that last one. Good, 24 out of 36. We know the sophomores. We're looking for the art people in that group. Now, this one is different. How come? Yeah, is there a question to ask like and or independent or any of those? Nope, it's just one thing. right? There's no compound probability at all. How do you figure that out?
Just 40.
40, yep, out of 115. Good job. Do you feel like this is getting kind of easier? Like you're getting the hang of it some? Okay. Let's do, I think this is coffee. Yeah. This one's interesting because how many of you are coffee drinkers? 3 of you? Okay. I'm curious what you think if there's a relationship between drinking coffee and sleep, but it says this. This kid wonders whether the amount of sleep he gets is related to the amount of coffee he drinks. So for about 10 weeks, he records how many cups and how many hours he gets for sleep. So what are our two events?
Cups and
Coffee.
hours.
Yeah, good. Cups and hours. So what is the probability? And then you guys tell me what this says. Probability that he drank 2 cups, given that he got 6 hours. Okay? So I think you're good on the scenario. I'll let you go ahead and answer these 2 questions on your own, and then we'll check them. Okay, so 2 cups given 6 hours. So is hours or cups the category? Hours. So we go to 6 hours horizontal, and then 2. So this is 13 out of 27, and 48%. And then this one, hours given cups. Cups is our category, and we're looking for 7 out of the 1 cup category. So 9 out of 26. Or 35%. It says surrounded the nearest whole. How'd that go? Awesome. So I kind of like these. What are you guys thinking? Seem okay? Okay, I think so. That's good. That's probably why I like them too. We're going to come back to this tomorrow. That's the test for independence that I was telling you yesterday. So, we'll come back to those. Grab your packet, please. Yep, let me get down there to it. This one. And go to page 9. Alright, so this is data from us. So we're going to create our own table of values. So, everybody has to look around. Are Converse? No, yeah, those are Converse. Are those considered sneakers? Okay.
No.
We're going to say yeah. Alright, so, boy wearing sneakers. Looks like both of you are. What? Those look like sneakers.
I guess.
Yes. 0. So 2. That was easy. Well, wait. Count me in here. I am not wearing sneakers.
They kind of look like it.
These are not. They're hiking shoes.
They're supposed to be
They
like
look a
kind of
lot
like
like
a
sneakers.
smaller type of boot. Because they're like the boot section of everything.
Are they like Vans or something?
No.
I mean, that style?
These are really extreme shoes. If they tied in their sneakers.
They're not.
I mean, if they're not boots, then.
These are boots.
Those are boots, yeah.
But those are sneakers.
Yeah.
Alright, we're going. I like Bailey's definition. Alright, girls. Are all of you wearing sneakers? Okay. Well, raise your hand if you are. 1, 2, 2. Okay. I don't know, I'm like waiting for you to decide. Sorry. You know what you're wearing. And then what are there? 5 of you? 3? Okay. Alright, so go ahead and do your totals. And this is specific to our class now, like the probabilities that we calculate. I'm just seeing how far I want you to go with this on a little work time.
I have no idea.
Huh?
I didn't get the sheet.
Yes, we had this sheet for like a week.
When? Last week?
It's the one with like the cards and the dice on the
Oh,
front.
what? I just didn't flip it over.
Okay, this is going to be a good review. So go ahead and do down all of page 9, and then we'll come back and check. What do you think? Like 5 minutes, maybe?
Yeah.
6? So A, suppose you select a student at random. What's the probability the student is wearing sneakers? Well, that would just be 4 out of the total, right? There's no compound multiple event things. So 4 out of 8. Suppose you select a student at random. What's the probability that the student is a girl? Well, now we have to go a different direction, and it's 5. Does the multiplication rule correctly compute the probability? What has to be true for this to be used? What? It is. So in order to use the multiplication rule, that rule is, where is that? It's this one. Where did I write it? There it is. This is the one we're talking about. That's called the multiplication rule. Do you want to write that title on there? I don't really relate to it that way, but when can we use this? It has to be independent, right? So are these, is being a girl, yeah, here I am. Is being a girl and wearing sneakers independent? No, because think about walking into this class right now. The girls have a different probability of sneakers than the boys do. We are 66%, you girls are 40%. So knowing that it's a girl changes what you would answer, right? So, no, it's not independent. Guys, but being able to determine it's not independent, number one, that's really important. So make sure you're staying up on that. Number two, you can't always just eyeball it. So that's why we're going to talk test for independence tomorrow. Okay, how is this situation different from previous ones in which you could use the multiplication rule? What are we going to say there? Okay. And by the way, when it says in the situation different from previous, is talking about pages 4 through 8. All of those were independent, right? All right, what's the probability that a randomly selected student is a boy? Or we haven't done in a couple days, is not wearing sneakers. So what's our question now with or? We have to switch gears a little. This is why it's kind of a review problem. What's our or question? Mutually exclusive. Is being a boy and wearing sneakers mutually exclusive? No, because we have two right here that are both, right? A boy and boy and wearing sneakers. So this is not mutually exclusive probability. So what's the formula for not mutually exclusive or probability? B or or sneakers. Probability of boy or sneakers. What's the formula? Plus, good job. Good. But not done yet. Minus both. Good. With this table, all of those are really easy to get. Okay? So what's the probability of being a boy? 3 out of 8. Probability of sneakers, just in general? Plus 4 out of 8. Minus the both boy and sneakers. 2 out of 8. Everybody see where we got that? So there's 2 boys out of all of us. There's 2 boys that are wearing sneakers. So 3 plus 4 minus 2. That is 5 out of 8. Shoot, I'm doing not sneakers. My fault. You guys have to tell me when I'm being stupid. Huh?
So, yeah.
It should be minus 1 out of 8. That's just me. I'm a boy but not wearing sneakers. Okay. What is the probability that a randomly selected student is wearing sneakers or is a girl? Does it matter that we switched, like up here, it was boy or sneakers, now it's sneakers or girl? Does that matter, the order? No, because it's addition. Are these mutually exclusive? No, because we have, what was it, 3 of you? No. 1, 2, no. 1, 2 of you that are girls and wearing sneakers. So it's not mutually exclusive. Alright, so probability of sneakers or girls, same thing. Meaning we have to sneakers plus girl minus both. How many, what's the probability of sneakers again? 4 out of 8 plus probability of a girl 5 out of 8 minus both a girl and sneakers 2 out of 8. So that is 7 out of 8. We have a pretty good chance of hitting on that one, don't we? How'd that go for you? Okay. Alright, next page. This one is more like what you'll see on your test. So, I'm going to let you work that. Let's see how far down you need to go for tonight. Just do down to here through F. We'll start talking about tests for independence after that. So this is homework, please.